Welcome to springlib.
So the first sequence is the constant sequence equal to 3. Since this is constant, that means it doesn't change. So we can just put A1 is 3 and the next element is exactly the same as the previous one. Now for the second sequence, AN is given by 2n. And now it is just, well, let's compute A1 is 2. Now AN plus 1 is by definition twice n plus 1, which is 2n plus 2. But 2n now is an plus 2. And therefore the wanted relation is an plus 1 is equal to an plus 2. Now, for the third sequence, you have an is equal to 2n plus 3. And again, the first entry is 5. And an plus 1 is twice n plus 1 plus 3, which is 2n plus 3 plus 2. And we recognize this as an plus 2. Now, the fourth sequence, an, is given to as 5 to the power of n. Well, the first entry is 5. Then the the next entry is just, well, 5 to the power of n plus 1. And this is by definition of power 5 times 5n. And therefore, this is 5 times an. Then we have the sequence n squared. So the first entry is 1. And now the next entry is n plus 1 squared, which is n squared plus 2n plus 1. And n squared is an. So it is an plus 2n plus 1. Then we have the sequence n squared plus n. And, well, the first entry is 1 plus 1, so 2. Now the next entry is n plus 1 squared plus n plus 1. This is n squared plus 2n plus 1 plus n plus 1, which is, well, let's rearrange this as n squared plus n. And then we have the other terms, which is 2n plus 2. But now we recognize this as an plus 2n plus 2. Then we have the sequence an, which is given by n plus minus 1 to the power of n. So let's compute the first element. The first term is 1 plus minus 1 to first power, which is 0. Now the next entry is n plus 1 plus minus 1 n plus 1. But this is n plus 1. Well, let's write it explicitly. Plus minus 1 to the power of n that multiplies minus 1. So it is n plus 1. Then we have minus 1 to the power of n. we can write these as n plus 1 plus minus 1 to the power of n minus twice minus 1 to the power of n. So that we recognize n and n minus 1 to the power of n as an. And then we have plus 1 minus twice minus 1 to the power of n. And finally, we have the sequence given by the factorial. Recall that the factorial is defined as 1 times 2 times 3 times all the way up to n. So in particular, we see that a1 is given by just 1 that multiplies, well, just 1, so 1. Now an plus 1 is, well, it's the product 1 times 2 times all the way up to n plus 1. So that means that it's also multiplying by n. But now we recognize the first product as just an that multiplies n plus 1.